Page 303, question number 3. A skateboarder with a mass of 65 kilograms increases his speed from 1.75 meters per second to 4.2 meters per second as he rolls down a ramp. What is the increase in his kinetic energy? So in this case, we're looking for the change in kinetic energy. That's going to be the final kinetic energy minus the initial kinetic energy. So the mass doesn't change, so we have mv final squared divided by 2 minus mv initial squared divided by 2. Now, in this case, I'm going to start off by factoring. Now, you have to be careful when you factor these. We're going to divide both of them by m and factor out the 2 as well. So we're going to have m divided by 2, and we're going to have v final squared minus v initial squared. Now, when you're doing this, be careful. A lot of people go v final minus v initial and then square everything. You cannot do that. You have to square them before we subtract. So I'll do this both ways to show that that's what gives us the same answer. So in this case, we have a mass of 65 kilograms. V final is 4.2 meters per second. And V initial is 1.75. Again, we have to square both of those. So 65 divided by 2 times brackets 4.2 squared minus 1.75 squared, close brackets, gives us 473.76875. Kinetic energy is measured in joules. With 3 significant digits, we can round that off to 474 joules. Now, the second option here is to take this and substitute our numbers directly in. So we're going to have 65 kilograms divided by 2 times our velocity final 4.2 squared minus our second energy 65 times 1.75 squared divided by 2. And when we plug all of that into our calculator, 65 times 4.2 squared divided by 2, we end up with 573.3 minus 65 times 1.75 squared divided by 2 gives us 99.53 joules. So 573.3 minus 99.53 gives me a value of 473.77, which again rounds to 474 joules. So either method will give us the same value. It's important to remember to square the values before you subtract.